Before we begin with the actual syllabus, let us try to revisit the concepts of curl, gradient, and divergence. If we assume a function t to be a function of three independent variables x, y, and z, then if we differentiate that function d, it appears in this following manner: dt is equal to dou t by dou x. Since t is a function of x, we differentiate it partially with respect to x, and then we take the derivative of x plus dou t by dou y into dy plus dou t by dou z into dz. Now this entire expression can be rewritten as dou t by dou x x cap plus dou t by dou y y cap plus dou t by dou z z cap. This is a vector quantity. This can be dotted with dx x cap plus dy y cap plus dz z cap. Now we should note that these x cap, y cap and z cap are just the unit vectors along x, y and z axis respectively. In some textbooks, they are also denoted by letters I cap, j cap and k cap. Any convention would be conveniently followed. Now, as we know that this entire expression is written as infinitesimally small line element dl bar, which includes an infinitesimally small displacement along x, along y and along z together. Similarly, this can be written in a shorthand notation as del t bar. We should note that both these quantities appearing in the parentheses are vectors. So we have put a bar over it. Now this notation del, which is used instead of this large expression dou by dou x x cap. In fact, let us write it as x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. When this del is operated over the function t, we get a vector expression corresponding to the term in the parenthesis. So we see that this differentiation of the function t is simply del t bar dotted with dl bar. This is how we differentiate a function of three variables x, y and z. If we interpret this expression del t bar by using the definition of dot product, we see that dt is magnitude of del t bar into magnitude of dl bar into cosine of theta, where this theta is just the angle between del t bar and dl bar. Now if we put theta to be equal to 0, obviously in that case cos theta is 1, which is the maximum possible value of cos theta. And if we fix this magnitude of dl bar, suppose that is fixed, we see that dt is maximum when del t bar and dl bar have the same direction. That is, as we can see, if both these values are given some, or both these expressions are given some value, then we see that maximizing cosine theta maximizes the dt, and maximum value of cosine theta, which is 1, corresponds to theta equal to 0 degree, and theta equal to 0 degree means that del t bar and dl bar are along the same direction. That's what we have interpreted. So this also gives us maximum change in t. So this is how we can interpret this term del t bar, that it gives the direction of maximum change in the function t. This operation is called as gradient. We should note that gradient is written as del t bar. Gradient makes the del operator to operate on a scalar function. It operates on a scalar function, but the result is a vector. Now, since we have defined this del operator as x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z, and we have already defined one operation using this del operator and called it as gradient, we can have two more such operations. Because this del is a vector, and a vector can have two types of products, namely a dot product and a cross product. So let us discuss the first case of dot product. So suppose a bar is a vector function which has three components, ax x cap plus ay y cap plus az z cap. Then we can write it as del dot a bar being equal to x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z dotted with ax x cap plus ay y cap plus az z cap. So by the definition of dot product, this gives us dou by dou x of ax plus dou by dou y of ay. Just we are linking the x, y and z component, plus dou by dou z of az. Now we see that the result is a scalar, and the del operator operates on a vector through a dot product. This type of operation is called as divergence. It gives us an estimate of how diverging or converging a vector field is. If the divergence is positive, the vector field must be of this type, and if the divergence is negative, the vector field must be of this type. Similarly, the next step is to define the cross product of del with a bar. So del operates on a bar, which is a vector, through a cross product. Now obviously a cross product is going to give us a vector result. This type of operation is called as curl. If we want to define this, we need to use the definition of cross product. So we write it as x cap, y cap, z cap, dou by dou x, that is the three components of the first vector, dou by dou x, dou by dou y, dou by dou z. Then the third row of this determinant would be the three components of the second vector, ax, ay, and az. Now this determinant can be expanded and solved, which will be having three components, and the resultant is going to be a vector thus. This operation gives or tells us about the curly nature of the vector function. The curl need not always be of this type. It can also be of this type, that half of this region gives us, let us say, x, y and z axes are fixed like this. Then half of the region gives us the vector field in positive y direction, and the other half of the xy plane gives us the vector field in the negative y direction. So such type of vector fields are also going to show curly nature. Once we have known these three fundamental operations, we can proceed further. Thank you.